Okay, hello everyone. So this short tutorial is about ER diagrams in relational databases. So we will start with, first of all, what is a database? It is a collection of relations, or also known as tables. And each relation will have a set of attributes, where attributes are the properties of a particular table. Now each table or a relation will have a key, and key is known as a set of attributes that uniquely identifies a tuple, meaning that each row will be uniquely identified by this key, and we call this key as a primary key. So for example, if we look at the table called user, that has three attributes: UID, name and age. UID is the primary key because it is underlined. Name and age are other attributes. Now in this case, why are we not choosing age as the primary key? Because age can become duplicate, meaning there can be more than one user with the same age. It's not unique. It can be duplicated and it can be redundant in the table. Okay. So whereas UID, every user is going to have only one ID associated to them, and therefore UID is the primary key rather than the age. Similarly, name can be redundant. There can be more than one user with the same name, and so we cannot select name as the primary key. Sometimes, in some cases, a combination of two attributes is selected as a primary key. So for example, UID and name can become a primary key, but in this case it will not, because it is not minimal, right? Not minimal meaning that if we can have a minimum of UID as a primary key, then why should we choose two attributes in order to make a primary key? In certain situations and scenarios, there are cases where there is no primary key, and so you choose the minimum two attributes to prepare a primary key. Now moving on, we will look into the concepts of primary keys and foreign keys in the further lectures. But for now, let's now move into the ER diagram. So ER diagram basically is the relationship diagram between different entities. An entity is a thing or an object, right? An entity set is the collection of the same type of object, or we can say a class of different objects, and it is represented by a rectangle. Now association between different entities is represented by a relationship. Attributes are the properties of the entities, and they are represented by an oval symbol. Different association between entities is represented by a diamond shape, and it is also known as a relationship set. Now, an example of ER diagram. So here we have two entity sets, users and groups. Users is member of groups. In users, we have two attributes, UID and name. UID is the primary key of the user's entity. In the groups, we have two attributes, GID and name. GID is the primary key for the group's entity. Now the keys are always underlined, as we know, and they are primary keys. Now there are different types of relationships. In this particular case, it is a many-to-many relationship. Many-to-many relationship stands for where one entity can be associated with another entity with many types, meaning many users can become member of many groups, and in the same way many groups can have many users, right? Let's look into the other kind of a relationship, such as many to one. So meaning where one entity is in a relationship with many to one relation. So meaning many courses can be taught by one teacher. So if we look from the courses point of view, there are many courses and they can be taught by one single teacher. So it is many to one. But if we reverse it, it becomes one-to-many. So if we look from teacher's point of view, one teacher can teach many courses. So it is one-to-many, right? There is another relationship called one-to-one, meaning where only one user can have, let's say one user can have only one account. So it's a little bit more restricted, where you cannot have more types of one entity. So one user can have one account. Okay, so it's one-to-one. Moving on to weak entity sets. So a weak entity in ER diagram is those entities that cannot exist independently. So they need a strong entity in order to exist, and they have to adopt the attributes from the strong entity. So in this case, we have buildings as a strong entity which has two attributes, name and year. Okay, name is the primary key, so unique to the buildings, and year is the year that the building was built. Now buildings have rooms, right, or rooms are in the buildings. Rooms cannot exist independently, so they are weaker entity, and so they are represented by the double rectangle. And the rooms will have a primary key, either the number or a composition of name and the number. We also know that, for example, there is a building called annex building. So the room number would be, the initials of the room number would be the building name, annex, and then the starting would be the number. So annex 210. So annex is coming from the building name, and then 210 is the room number. So meaning rooms are dependent, really practically rooms are dependent on the building. If there is no building, room name and number cannot exist. Okay, so we can have a composite key of name and number in the rooms as the primary key, or it is adapting the name from the buildings. And capacity is another attribute in the room, which stands for number of people that can be accommodated in the room. Now moving forward, now let's look at another ER diagram or a case study. Now in this one, we are designing a database for states, counties and cities. Okay, now counties and cities, they cannot exist independently without the state. So state is a strong entity, whereas counties and cities, they are the weaker entities. So state is having one primary key called name, so unique name, each state having a unique name. Name is PK, and states is capital of cities, right? Cities cannot exist if there is no state, so it is a weak entity having two attributes, name, population and location. Name is unique to each cities, right? So names of cities are unique within the counties. Then again, cities are within the counties, okay, and counties are having two attributes, name and area. And counties again is a weak entity because counties cannot exist if there are no states, right? So this particular, there can be other ways of designing this diagram where cities and counties are dependent upon the state, okay, and cities are adapting their location from the states, and counties are adapting their location from the cities. So we will move further in the second. We will look at the more case studies related to ER diagrams in the next lecture. Thank you.